My name is Jason Morris. I am a lawyer at Round Table Law. I am a consultant with Lemma Legal Consulting, and I am currently a master's student in computational law at the University of Alberta. This is a video version of a presentation that I did at the Regulatory Innovation Showcase about blocks.com. Blocks.com is a tool that I have developed in order to make rules as code easy for non-programmers. So I'm going to start by talking about an analogy, and that is to self-driving cars. So imagine you have a self-driving car and you want to get a coffee. You know where you are, you know where you want to go, and you know the roads in the area. So you give all of that information to a programmer. The programmer generates a set of directions for the car to follow and loads them into the car, and the car gets you to the coffee shop. This is clearly a bad idea unless you are a programmer or you're willing to pay one to follow you around all day. But strangely, this is effectively how we build legal apps today. Here's the analogy. Getting a self-driving car to take you somewhere is like getting an automated system to answer a legal question. Destinations are like questions. Your starting location is like a fact scenario. The roads are like the rules. Directions to get from point A to point B are like an algorithm for answering a question. At the end, you get where you want to be, or you learn what it is you wanted to know. Except that the difference between getting a computer to answer a legal question once and getting it to answer the same legal question a million times is really small. Unlike transportation, the marginal cost of computation is nearly zero. So really the analogy is between getting a car to take you somewhere and building a legal services application. So what can we learn from the way that we actually do navigation? Well, the first thing you do is you get a programmer to take that process of a starting location, a destination, and map, and turning that into a set of directions. You get them to automate that process, turn it into a piece of software that other tools can use, which I will call a wayfinder. The next thing you do is you replace the programmer in the original story with the wayfinder. The wayfinder then gets the information about the environment, the map, from a central location that's been digitized and maintained by experts, and can even be up to date with regard to things like road closures or accidents. And then third, you get the user's location from the GPS, so the wayfinder doesn't even need to ask the user where they are. Now all the user needs to do is provide their destination, and everything else is taken care of for them. This is better for a lot of reasons, but here's two. First, the user doesn't need to know the map, and second, the user can get directions to multiple different places from multiple different origins easily with the same tool. So what does this mean if we apply it to rules as code? Well, for rules as code, what you would call a wayfinder is a piece of software called a reasoner. A reasoner is a piece of software that knows how to take digitized rules and a question and generate an algorithm for answering that question. And then the second thing is you digitize the rules in the same way that you digitize the map. So this is what your rules as code expert would be responsible for doing. They can create a centralized digital set of rules so the app developer doesn't need to know what they are. Now, all the app developer needs to provide is the question. So the same advantages are the legal app developer doesn't need to know the rules that they are implementing, and they can develop multiple apps really quickly using one encoded rule set, which is a pretty surprising claim. So I want to show you some examples. Now, for our example, we're going to need a law to encode. So I have used the Australian Beard Tax Act of 1934, which is an imaginary law created by the Service Innovation Lab in Wellington, New Zealand, as our example piece of legislation. This is a part of what it looks like, and this is what it looks like when it is encoded in blocks.com. So a short aside, my LLM research at the University of Alberta involved a survey of all the tools out there for rules-based programming. And basically what I found is that there's some really awesome tools that could exist and just don't yet. So as much to prove it to myself as anyone else, last December I started building one of those tools and it turned into blocks. The features that I'm demonstrating in this video and that I demonstrated last week in Ottawa have only been in the live alpha version of the software for a couple of weeks. So this is very new. So this is what the Beard Tax Act looks like when it's encoded in blocks. This was then saved to a file, and that file was loaded up onto the web. So that's the rules as code part. That's the digitizing the law. Next, the app developer needs to ask their question. What do you want the app to do? Now I've already built an app, and this is what the code for that app looks like. The first block just says, I want to ask a question about the beard law. And the second block says, tell me about all of the people who have prohibited facial hair. So this gets saved to a file, and that file is loaded up to DocAssemble, where the DocAssemble interview uses it in order to answer that question. Now note, the person creating this app in DocAssemble doesn't need to actually know what the rules inside the Beard Tax Act say. And here is what that application looks like. So it accepts a list of people with some details. The first person is going to be me. And my beard is about 7 millimeters in length. It is on my chin, and it goes from ear to ear under my nose. I do not have a beard coin, nor have I paid the beard tax, and I do not wear a beard for religious or cultural reasons. I actually live in Canada, but I'm going to say Australia so that the law actually applies to me. And then I'm going to tell it about one more Canadian with a beard. And we're going to say that Santa's beard is quite long. It is on his chin. It does go ear to ear under his nose. He does not have a beard coin. He has not paid the beard tax, but he does wear a beard for religious or cultural reasons. And we'll pretend that he lives in Australia. Now what the app is going to do is send that information to the blocks.com server, which will download the digitized rule off the internet, figure out what the answer to the question is, and send it back. And you can see the answer is that I have prohibited facial hair. So that's what the app looks like, but I also said that it would be very easy to generate multiple apps like this. So let's do that too. This is what the code looked like for the has prohibited facial hair app. So let's create a different one. I'm going to copy this reference to the online encoded law and clear the workspace. And while it's empty, you can see that Blocks does not know about any categories, objects, or attributes. When you copy that in, it now knows about the categories, objects, and attributes in the encoded law. So we can use those to ask our question. And our question is going to be, who is exempt from the beard tax? So their entitled to exemption value is going to be set to true. We're going to call them the person. And then in order for DocAssemble to know what to display, we're also going to find out what the person's instance name is. There. That file is called exempt.blocks, and it is uploaded to the DocAssemble server. And then we need to go into the source code for the DocAssemble interview and make two simple changes. First, this question we're going to get rid of, and we're going to replace it with the question in exempt.blocks. Second, on the last screen of the interview, We are no longer answering the question about prohibited facial hair, so we need to change the text that's displayed to is exempt from the beard tax. We save, and that's it. If we go back into the interview that we were already running, we can go back one step and then finish the interview again. It's now sending that same data to Blocks, but with a different question. Blocks is downloading the code, coming up with an algorithm to answer that question, and sending the answer back, which is, of course, that Santa Claus is exempt from the beard tax. So this is not a new kind of technology. The technology powering this has existed for about 40 years, and there are a lot of tools out there. And it's not entirely new to use in governments either. In particular, Oracle Policy Automation is a tool that uses similar technology, and it's used in the UK, the US, and New Zealand, and I'm sure other places as well that I'm not familiar with. So the question might be, what do we need Blocks for? Well, the requirements of rules as code, because it assumes that the encoding will happen at the same time that the drafting did, and that it's going to be done by people working in the public service, well, the requirements are different. It requires things that are features for legislative drafters and not just features for people building web applications. This is the list of things that I would like a tool to have, and eventually I would like to get Blocks to the point where it actually had all those tools, but it's not quite there yet. These are the people who provided the icons that were used in this presentation, all of which are available at thenounproject.com. These are the links to the live demo for Blocks. The app that I just showed you is also available to try online, and that is the GitHub link for the Australian Beard Tax Act if you'd like to try your hand at encoding it in another tool. And this is my contact information. If you're interested, the easiest way to get a hold of me is I am at Roundtable Law on Twitter. Thanks very much.